Now we are going to study preparation of haloarenes. Haloarenes meaning is halogen will be directly attached to benzene ring. So how to prepare is take toluene. Toluene is methyl group attached to benzene ring is called as toluene. Toluene when you are treating with chlorine or bromine in the presence of Fe, that is in the presence of iron chloride, so which is a Lewis acid, in dark condition you will get two products. That is, this halogen will be substituted at the ortho position and para positions. So you know that this will be the ortho position. So one product you will get at the ortho position and this is the para position, and halogen will be substituted at the para position. So this ortho and para product can be separated easily because they have huge difference in their melting point. So melting point of para product will be high when compared to that of the ortho product. So what is the reason for that is, the reason is it is a symmetry molecule. Since it is symmetric molecule, it fits well in the crystal lattice. So that is why para product will be having high melting point. So here if you are using iodine, so if you are using iodine, you have to use oxidizing agent like nitric acid or HiO4. So because the iodine which is used here, in the product you will be getting Hi. So when you are using the oxidizing agent, the oxidizing agent will convert Hi back to iodine. So it will become a reversible process. So here you can see reaction with iodine are reversible in nature and requires the presence of oxidizing agent like nitric acid or HiO4 to oxidize Hi formed during the iodination. Fluoro compounds are not prepared by this method due to high reactivity of fluorine. So we are not using fluorine because it is highly reactive in nature. So we are going to use chlorine, or you can use bromine in the presence of Fe. So you will be getting these two products. When you are using iodine, you have to use strong oxidizing agent like nitric acid or HiO4. Next is Sand-Meyer's reaction. So this is very important. So many times this question is asked in the NEET examination. So here you have to take aromatic primary amine. So here aromatic primary amine is aniline. So this is aniline. Aniline is NH2 group. If it is directly attached to benzene ring, it is called as aniline. So aniline you are treating with sodium nitrite plus Hi. The temperature should be very low. So at cold condition, that is 273 to 278 Kelvin. So if you convert to degree Celsius, it will be 0 degree to 5 degree Celsius. So temperature is very low, you have to maintain. So you will be getting benzene diazonium salt will be formed. So this is the salt which is formed. So when you are treating this with cuprous chloride, what will happen is this chlorine will be substituted here. So you have to remove this and then place chlorine. So you will get chlorine directly attached to benzene ring. So in place of CuCl2, that is cuprous chloride, if you are using cuprous bromide, Cu2Br2. So what is the product obtained? So in this place bromine will be attached. So here you will be getting Br. So depending on the reagent, you will get chlorobenzene or bromobenzene. If it is cuprous chloride, chlorobenzene. If it is cuprous bromide, Cu2Br2, then it will be bromobenzene will be formed. So if you want iodine to be attached, so you have to treat benzene diazonium salt with potassium iodide. Then this iodine will get attached here. So you will be getting iodobenzene as the product. So this is Sand-Meyer's reaction. So you can see here which is given. You can go through it once. So everything in the condensed form I have given here. So revise this several times. So next we will see example. Write the product of the following reactions. So first one. So here you can see a compound is given. It is treated with HBr. So whenever HBr is there and there is a double bond, so you have to use Markovnikov's rule. So what you have to do is you have to break this double bond. So when you are breaking this double bond, hydrogen should be added to one carbon atom and bromine should be added to another carbon atom of the double bond. So where you will add is according to Markovnikov's rule. Hydrogen should be added to the carbon atom containing more number of hydrogen atom. This carbon, how many hydrogen atom it has? It has only one hydrogen atom. This carbon, how many hydrogen atom it has? It has two hydrogen atoms. So more hydrogen atom it has. Therefore, hydrogen should be added to this carbon and bromine should be added to this carbon. So here you can see this is the product obtained. Second, so again you can see there is a double bond and HCl is there. So use Markovnikov's rule. So break the double bond, add hydrogen to the carbon containing more number of hydrogen atom. So here you will add to this carbon and chlorine you will add to this carbon. So you can see this is the product obtained. And here again you can see there is a double bond and there is HBr. So whenever peroxide is there, so it will be anti-Markovnikov's rule. So if peroxide is absent, then it will be Markovnikov's rule. If peroxide is present, then it will be anti-Markovnikov's rule you have to use. So here anti-Markovnikov's rule is hydrogen should be added to the carbon containing less number of hydrogen atom. So this carbon is having less number of hydrogen. So add hydrogen to this carbon and add bromine to this carbon. So you can see this is the product which is obtained. So next in text questions we will see why sulfuric acid is not used during the reaction of alcohols with hydrogen iodide. So already this I discussed in the first video. So why we are not using sulfuric acid is sulfuric acid is a strong oxidizing agent. It will convert Hi which is formed in the reaction to iodine. So that is why we are not using sulfuric acid. Second, next question, write structures of different dihalogen derivatives of propane. So propane means how many carbon atoms will be present? There will be 3 carbon atoms present. Dihalogen meaning is 2 halogen you have to add to propane. So see here, these are the 4 possible product. So 3 carbon atom, propane means 3 carbon atom. So dihalogen means once halogen attached here and second halogen attached to this carbon. Another probability is attached to this carbon and then halogen to this carbon. Third probability is to the same carbon, terminal carbon we can attach 2 halogens. And next probability is to the center carbon we can attach 2 halogens. So these are the 4 possible products obtained in the for propane. Next, among the isomeric alkanes of molecular formula C5H12, identify the one that on photochemical chlorination yields. So here a single monochloride. So single monochloride means the compound should be having only one type of hydrogen. So see here, this is the answer. How many types of hydrogens are present here? See this. Here hydrogens are attached to this carbon. So this carbon is primary carbon. Even here hydrogens are attached to this carbon and this carbon is primary. Even this is primary carbon, this is primary carbon. So all the primary carbons are attached to this carbon. So all the hydrogen atoms here are equivalent in nature. Therefore, it will give monochloride, single monochloride. So the answer for first one will be this. 3 isomeric monochloride, meaning is 3 means 3 different types of hydrogen should be present. So this is the answer. So let us see whether 3 types of hydrogen atoms are present in this. So see here, this is a symmetric molecule. That is exactly you can break this into 2 half. So here this is one type of hydrogen, second type of hydrogen and third type of hydrogen. So 3 different types of hydrogens are there. So this will form 3 isomeric monochloride. So this is the second answer. 4 isomeric monochloride means 4 different hydrogen atoms should be present. So see in this compound whether 4 different hydrogen atoms are present. So this is primary carbon, this is secondary carbon, this is tertiary carbon, this is primary carbon, this is primary carbon. So here you can see 3 primary carbons are present. Out of these 3 primary carbons, these 2 are same because these 2 are attached to tertiary carbon atom. So these 2 will be one type of hydrogen atom. This is second type, this is third type, this is fourth type. So 4 different types of hydrogen atoms are there. Therefore this will give 4 different isomeric monochlorides. So answer for this will be this. Next, 6.5, draw the structures of major monohalo product in each of the following. So you can see here thionyl chloride is there. So in the preparation of alcohol, in the first video we studied this reaction of thionyl chloride, which is a good reagent for the preparation of alcohol. So if OH group is there, remove OH group and place Cl over there. So what is the product you will get? You will get product like this. So in place of OH, Cl you have to place. Second, so reactant is given bromine in the presence of UV light. So whenever bromine is there in the presence of UV light, it is free radical mechanism. So if it is free radical mechanism, don't touch the double bond. So here side chain, see which will form stable free radical. You know that tertiary free radical is stable than secondary, which is stable than primary free radical. So here if I form free radical, this is primary. If I form free radical, this is secondary. So secondary will be more stable. Therefore remove one hydrogen from here and place bromine from here. So here the product can be written like this. So here CH, Br, CH3 and then NO2. So this is the product. Next here HCl is present and you can see 2 alcohols are present. So which alcohol you have to substitute with chlorine? So here always remember, if alcohol group is directly attached to benzene ring, so this is very difficult to break this bond because this will be having the partial double bond character. So that is why breaking this bond will be difficult. So only you have to replace this with Cl. So remove this OH and place Cl over here. So this will be the product. So next is there is a compound and here HI is given. So whenever you see a double bond and HI, so what you have to think of is, you have to think of Markovnikov's rule. So break this double bond, add hydrogen to the carbon containing more number of hydrogen atom. So here this carbon has 1 hydrogen atom and this carbon doesn't have hydrogen atom. Therefore add hydrogen to this carbon and add iodine to this carbon. So what is the product obtained? So you will be getting product like this. So here CH3, I and then here H. So already 1 hydrogen is existing here. So this is the product which is obtained. So next, so reactant you are treating with sodium iodide. So this is halogen exchange method. So in the first video we have already studied halogen exchange method. So bromine you are exchanging with iodine. So you will be getting here CH3, CH2I. This is the product. So next again here you can see there is a double bond and here there is bromine in the presence of UV light. So again this is a free radical mechanism. So students, whenever it is a free radical mechanism, don't touch the double bond. So because bromine in the presence of UV light, it undergoes free radical mechanism. So here this carbon atom will be having 1 hydrogen. So here removing that hydrogen form 1 free radical over here, or even this carbon can form free radical over here. It is one and the same. So here the product will be, so double bond you keep as it is and here you have to attach bromine because free radical should be formed here. The free radical which is formed here is more stable. So therefore attach bromine to this carbon. So this will be the product. Next is physical properties. So what is very important under physical property is you should know about melting point, boiling point and density. So how you will learn about this melting point, boiling point and density is boiling point. If you consider for hydrocarbon, the boiling point will be less compared to that of haloalkane. That is 1 hydrogen you will be replacing with halogen. This is haloalkane. See here, because the mass of hydrocarbon will be less when compared to the mass of the haloalkane. So if the mass is high, boiling point is high. So remember this trick. Boiling point is directly proportional to the mass. If mass increases, boiling point also increases. So the mass of haloalkane will be high, therefore boiling point also will be high, and here the boiling point of hydrocarbons will be less. So here I have made a note of it, you can see here. And again, if you are comparing iodine, that is haloalkane, where iodine is present, then bromine, chlorine and fluorine. So here for iodine it will be greater, boiling point will be greater compared to bromine, then chlorine and then fluorine. So what is the reason for this is again because of mass. You know that iodine has greater mass when compared to bromine, chlorine and fluorine. So because of higher mass, so this will be having higher boiling point. One more reason is because of charge difference, there is greater force of attraction. So you can see here the reason is given. Increase in size and mass of halogen atom, the magnitude of van der Waals forces also will increase because of difference in their sizes. So van der Waals force of attraction also will be more, because of which the boiling point will be in this order. So you can learn from here. And then if it is branching compounds are given, see here if 3 compounds are given, you have to compare which is having more boiling point and which is having lesser boiling point. Use this trick, that is boiling point is inversely proportional to branching, meaning is greater the branching, boiling point will be less. See here there is no branch. Here second compound 1 branch is present. In the third compound you can see 2 branches are present. So more number of branches are present here. So greater the number of branches, boiling point should be less. So see the boiling point 346, and here you see 375 and here 364. So therefore no branching, boiling point is high. Branching is present, therefore boiling point is less. So use this trick. So boiling point of isomeric dihalobenzenes are very nearly the same. However, para isomers are high melting as compared to their ortho and meta isomers. So this already I told you that para will be having more melting point. We are talking about melting point. So para will be having higher melting point when compared to ortho and meta. This is because of symmetry. That is, para will be symmetry molecule and also it will fit exactly in the crystal lattice. That is why. So here you can see the order of boiling point and melting point. Boiling point, ortho will be greater and then para and then meta. Melting point, if you are comparing, para will be greater and then ortho and then meta. So now comparing the density. So density is directly proportional to mass of the compound. So more the mass, density will be higher. So this is very simple to remember. Remember, density will be directly proportional to the mass. So if mass increases, the density also will increase. And then coming to solubility. So this is very important here. So if you take haloalkane, so here I have written, so take one haloalkane and this is second haloalkane. So between two haloalkanes there will be force of attraction. Why there will be force of attraction? This halogen is having partial negative sign and this is having partial positive sign. Again here this carbon is having partial positive sign and halogen is having partial negative sign. Because of this charges, negative and positive charge, you can see there is force of attraction between them. So if you want to break this force of attraction, you have to supply energy. Now we will take water. So in water you know that there will be hydrogen bonding between two water molecules. Again to break this hydrogen bonding you have to supply energy. Here you can see there are two different types of bond. Here due to attraction there is a bond formed and here hydrogen bond is formed. So here two different types of bonds are there and you are breaking by supplying the energy. So now you take one molecule of haloalkane and then one molecule of water. So here again you can see a bond will be formed. When a bond is formed, energy will be released. The energy released will be very less in amount when compared to the energy what is supplied. Therefore, this will be highly unstable. Therefore, solubility of haloalkane in water is very less. Why? Because of two different kinds of bonds are present, and here the bond formed is also different. Therefore, solubility will be very less in water. So here you can see solubility of haloalkane in water is less, but solubility of haloalkane in organic solvent will be more because of new intermolecular attractions between haloalkanes, and solvent molecules have much the same strength as the one being broken in the separate haloalkanes and solvent molecule. Meaning is, instead of water, if you are taking organic solvent, here the attraction between the haloalkanes and attraction between the organic molecule and the bond formed, almost everything will be similar. Therefore, they are more likely to be soluble in organic solvent compared to water. So in water, less soluble. In organic solvent, they are more soluble. Arrange each set of, let us see the in-text question now. Arrange each set of compound in order of increasing boiling point. So you know that boiling point is directly proportional to mass. So if mass is more, then boiling point also will be more. So let us see here. So the first one is bromomethane. Bromomethane is CH3Br, bromomethane. Second is bromoform. Bromoform is CHBr3, is called as bromoform. Chloroform, you know that CHCl3. So same way bromoform is CHBr3. Next is chloromethane. Chloromethane is CH3Cl. And then dibromomethane. Dibromomethane is CH2Br2. So dibromomethane. So which is having more boiling point here? So let us compare. So which is having more mass here? So here chlorine is present. Let me take another color. So here you can see chlorine is present. Chlorine is present, and in all this bromine will be present. So chlorine has mass less when compared to that of bromine. So therefore this will be position number 4. So less boiling point. So let us compare these three now. This one, and this one. So here bromine atoms are more. So boiling point will be more because mass is more here. So this is number 1. And this 2 bromine atoms, number 2. And here 1 bromine atom, number 3. Chlorine will be having less mass, number 4. So this is the order of boiling point. Next is 1 chloropropane, isopropyl chloride, and then 1 chlorobutane. So 1 chloropropane meaning is 3 chlorine atoms and 1 halogen, that is chlorine, is attached. Isopropyl chloride is 3 carbon, and you can see 1 branch is present. And then 1 chlorobutane. Butane means 4 carbon atoms are there and 1 chlorine is present. So here 3 carbon, 4 carbon atoms are present. So therefore the mass will be high here. So this is number 1. So boiling point will be high here. And now let us compare these two. So I said you that boiling point is inversely proportional to branching. So that is, here there is a branch and here there is no branch. So since branching is present, boiling point will be less. So this is number 3 and this will be number 2. So I hope you understood. Since 4 carbon atoms are there, mass is very high. So halogens are present in all the 3 compounds, you can see. 1 halogen is present, 1 chlorine, and 1 chlorine. So that is that doesn't make any difference. But here carbon atom 4 are present. Here 3 and here 3. So since 4 carbon atoms are there, mass will be high. Therefore boiling point will be high. This is number 1. If branching is there, boiling point will reduce. Here there is no branching, therefore this is number 2 and this will be number 3 because branching is present. So this is the order. So I hope you understood. So students, remaining we will see in the next video. I hope you like the video. Students, subscribe the channel and also share this video with maximum number of students. All the very best, students.